Hello, my name is Jared Skeens and welcome to the Zoom room. Today I would like to do Pure Maths 1, the specimen paper for 2020. So the reason why I'm choosing the specimen paper is because we just went into the Cambridge Pure Maths, or actually all the Cambridge math for A-level, just went into a new syllabus cycle starting with 2020. So I wanted to use the specimen paper because the other past papers don't have any of the new content in it, whereas the specimen paper will at least give us a glimpse of the new syllabus material question types. So what I have on the board is actually some alternate versions of things that we'll get to a little bit later. What I want to get to right now is the specimen paper itself. So let me share screen here. And here you see the Cambridge International AS and A level. So I've written out a key for it. And here's Pure Maths 1, paper 1 for Pure Maths 1. And we see, and this is the specimen paper, and we see that this exam is 1 hour and 50 minutes. In the previous syllabus, the exams were 1 hour and 45 minutes. So we've gained 5 minutes. I still use the rule of thumb of 7 per 5. That is 7 minutes of time per 5 points of Cambridge question. And here you also see the new formula sheet. The F19 is the updated formula sheet that you should be using. And we also see that it is still 75 points total mark for this paper. Now, this particular paper has 12 questions on it. In the past, the normal test had about 10. There were a couple that had 11, but most of them had 10. Now that we've got the extra 5 minutes, this particular specimen paper has 12 questions. And instead of me doing 12 questions on the board, it might take a long time. So for sake of length of video and you not getting bored to death, I'm just going to run you through my own work on this syllabus paper. So here we go. In the first question, says the following points, A, B, C, D, and E, lie on a curve. The table below shows the gradients of chords AE, so that's from A to E, and also B to E. So here's the chord AE, the gradient is 4, and for the chord BE, the gradient is 3. So it says to complete the table to show the gradients of CE and DE. So from C to E and D to E, gradient is slope. So we're just going to use the old algebra slope formula, change in y over change in x. So 9 minus the 7.75 over 2 minus 1.5. And you can see you get 1.25 over 0.5, which equals 2.5, and we put that in the chart. Then we go to DE, so 9 minus 8.79, and 2 minus 1.9, and we get 0.21 over 0.1, which comes out to 2.1, and we also put that in the chart. That's worth 2 points. So we come down here and it says state what the values in the table indicate about the value of f prime of 2. Now f prime is your first derivative. And remember, first derivative applies to slope. So what do we see about the slope when x is at 2? So let's go back and look at our x values. So the x values in A are 0, then in B 1, then in C 1.5, then in D 1.9, and then E you finally reach 2. So as you move from left to right, your x value is approaching 2. And when you look at the slope, you have 4, 3, 2.5, and 2.1. And the 2.1 is not at E, it's the D to E. So our conclusion then, which is only a 1 point question here, is that the first derivative at 2 would be approaching 2 or equal to 2 by the time you get to E itself. So you can see it already went down to 2.1. So it's reasonable to conclude that by the time you get to E, the slope is now at 2. So moving on, we go into functions unit. And here we have a f of x and a g of x, so two different functions. And it says to solve this equation. Well, this equation has inverse function equaling a composite function. So let's start with the inverse function. Here's our f of x, y equals 3x plus 2. And you know the rules, switch x and y, solve for y. So we switched our x and y, and then to solve for y, we subtract 2, and then we divide by 3, and then I rewrote it in inverse function notation. And then over here, we have our composite function where the f goes into the g. So we take our f and plug it into the x that's in the g function. So now we have our 4 times, and then we put the f function in there, and we get 3x plus 2. And then don't forget the minus 12, finishing off our g function. And then you distribute 12x plus 8 minus 12, 12x minus 4. So we've done the inverse, we've done the composite. Now we set them equal to each other. So we have a fraction here, multiply everything through by 3, gives us 36x minus 12. Don't forget to distribute. Get x on the same side, so minus x gives us 35x. We add the 12 to the other side, get 10, then divide by 35, 10/35, so x reduces to 2/7. Moving on, we get to question 3, which is a series question. Arithmetic progression, first term is 7, nth term is 84, 3n term is 245. So here's our first term is 7, nth term is 84, and 3nth term is 245. Find n. Well, we've got two equations here. This one is just the starting point, not really much of an equation. These are the two equations we want to work with. And of course, arithmetic has both n and d in it. So we need to use simultaneous equations. So here's 84, that's the answer to the nth, meaning it's the n term. So 7 is the first term, n minus 1 times d. And when we work that out, we get an nd minus d. And if we solve for dn, which is the double variable here, we get 77 plus d. Now, we might not know what to do with that yet, so we got to come over here and see what we get. So here's 245. Here's the first term, and then we have the 3nth term, so 3n minus 1, because that's the number of term we are, minus 1 times d, the difference. So we distribute our d, and again we get this 3dn and a d. So our simultaneous equations have dn and d as the variables. So since we've already solved for dn over here, we can plug it in over here on this side. So we get 245 equals 7 plus 3 times, substitute in the 77 plus d, and then we have a minus d. So as we distribute the 3 through to get rid of the parentheses, we get 231 plus 3d, and then as we simplify it, 3d minus d is our 2d, and when we take this 231 and 7, which would be 238, and subtract it from 245, we get 7. Divide by 2, d is 7 halves, or 3.5, whichever one you want to work with. Plug it back into our d's of this equation. So that gives us 3.5n equals 77 plus 3.5. And combine those two, you get 80.5, divide by 3.5, n equals 23. So this would be the 23rd term, and this one would be the 69th term. Moving down to question 4, here we see a derivative notation here. So the equation is y equals f of x. We're given the derivative f prime of x, 1 over the square root of x plus 6 over x squared and has this f of 3 equals 1, meaning that our x is 3, the y is 1. So it's like giving us a point here. So f of 3 equals 1 is the same thing as x3, y1. It's a derivative, and it wants us to find the original function, meaning we're dealing with an integration problem here. So here is our integral. We have no bounds of integration. So we need to write these in exponent form because our rule for integration is an exponent rule. So we bring the x plus 6 up, and the radical would be 1/2, and bring it above the division bar makes it a negative 1/2. So x plus 6 to the negative 1/2 plus 6 times x to the negative 2. So this x squared comes up and becomes x to the negative 2. So this is what we are integrating. Again, we add 1 to the exponent. So negative 1/2 plus 1 is positive 1/2. We divide by that number, and when you divide by a fraction, you invert and multiply. So dividing by 1/2, same thing as multiplying by 2. Then over here, negative 2 plus 1 is negative 1. And when you divide by negative 1, our positive 6 now becomes negative 6. And then don't forget the plus c, because we have no bounds of integration. Now, to get the plus c, we need to plug in our point. So the 3 is the x value. That's why you see this little 3 here and here plugging into the x. And the 1 is the y value that we're putting in over here. It's our f of x. So the 1 goes here in the y place. So 3 plus 6 is 9. So we have 9 to the 1/2 times 2. Then minus 6. And then this is x to the negative 1, basically means divide by 3, because the 3 then goes down underneath the division bar. 6 divided by 3 is 2, and it's negative. So our 9 to the 1/2 power is 3 times 2 is 6. 6 minus 2 is 4. Subtract 4 over, and our c is a negative 3. And now we can write our function back with its original notation. So f of x equals 2 times square root of x plus 6 minus 6 over x minus 3. So there's our original function. Moving on to question number 5. This one is new material. It's one of the transformations, and the transformation section was new to the syllabus. So here we see a column vector, which gives us our x and y translation. Here is the original function, y equals x squared plus 3x plus 4. So when we plug in our translation values, remember, when you attach it to the variable, you change the sign. So technically out here, I could have put y minus 0. I just left it y, because there's no change in the y value, but it'd be y minus 0 equals x minus 2 squared. So remember translations, connecting to its variable, the x to the x. This is x over y, so that connecting to the x, you change the sign. So x minus 2 squared plus 3 times x minus 2 plus 4. Then you simplify it or expand it all out. So this gives us x squared minus 4x plus 4, and then 3x minus 6, so distribute the 3 through, and then the plus 4. So here's our x squared, minus 4x plus 3x is minus x, 4 minus 6 is a negative 2, negative 2 plus 4 is positive 2. So here is our original, or our, should say, this curve translated this column vector over gives us this result. All right. Now let's go down here. Here's another one. Again, y equals f of x is just any particular function. And so this would be y1 and x1. Now y2 becomes 3 times the original y. So y2 becomes 3 times y1, and our x now has a negative on it. So again, this is new material. Describe fully the two single transformations which have been combined to give the resulting transformation. So here, first of all, the negative on the x means we're reflecting our graph over the y-axis. So remember, negative on the x, you reflect on the y. If the negative had been outside, meaning it was on the y, you'd reflect over the x. So this negative x means we're reflected over the y-axis, and this 3 in the front, our y2 is 3 times y1, meaning that we have a stretch, that's the name of the transformation, is a stretch by scale factor of 3. So our original y is now 3 times as high on the y-axis. You can say with respect to the x-axis, so in other words, you're stretching from the x-axis, or you can also say parallel to the y-axis. So here's your y-axis, and you're stretching it parallel to the y-axis. So just two different ways of saying the same thing. So 1 point for the reflection, 1 point for probably the stretch, and I don't know if the other point is for the scale factor or for the statement down here. You can check the mark scheme. Now we move into number 6. This is a binomial expansion. Find the coefficients of x squared and x cubed in the expansion of 2 minus x to the 6th power. So if you notice, what I did is I used the mental approach, you know, the possible combinations that give you 6 by addition, 6, 0, 5, 1, 4, 2, 3, 3, 2, 4, 1, 5, or 0, 6. Now this one's particularly easy because there's no x in the A position. This is your A position, this one is the B position. So this is the A, and this column represents the B. So since there's no x in the A, then obviously you get the 2 from the B position, which would be this one. And for the cube, you would get it here in the B position. So you have 3, 3. Now let me stop the sharing for a second and just show you an alternative way that you can get that by looking over here. So here's number 6. You can say A plus B. This is the A and the B in the binomial expansion. And this is the n, or the exponent, to which the expansion is taken. So the A exponent plus the B exponent has to equal 6. That's why I made my little list of 6, 0, 5, 1, 4, 2, and so on. Then inside the binomial expansion, the A term had no x's. So 0a plus the B term had an x to the 1 power. So that's 1b. So 0a plus b equals 2. Well, obviously, since we had no x's in the A column, b is going to equal 2. Plug that in up here, and you can see that a equals 4. In the x cubed one, a plus b has to equal 6. Again, there were no x's in the A, there was an x to the 1 power in the B, and that now needs to equal the 3, or the cube on the x. And so since there's no a's, the b equals 3, plug it in, and you get a equals 3. This is the algebraic method. The method I did on the paper was more of a mental method, but it basically does the same thing, but a little bit faster. So let's go back to our screen share. And so we got the 4, 2. Don't forget the NCR. The N is the 6, and the R is from your B column. That's the 2. So 6C2 is the coefficient from Pascal's triangle, which is 15. Then the A column has 2 to the 4th power. So here's our 2 to the 4th power, and the B column is negative x to the 2 power. So that becomes a positive x squared. 2 to the 4th is 16. And 15 times 16 is 240. X squared, it's just asking for the coefficients. So 240 is the answer for that part. Then down here, we have our 3 and 3 to get our cubic. Don't forget the NCR, so N is 6C3, that's the second 3 from the B column. So 6C3 gives us 20. Then our A is a 2 cubed from the A column here is this 3, 2 cubed, and the negative x gets this 3 over here on the right. So negative x cubed is still a negative x cubed, but now the cube is on the x. 2 cubed is 8. So again, be careful of your signs when you're distributing exponents. 3 negatives is still a negative, and the 3 also distributes to the x. So it's like a negative 1 cubed and an x cubed. Gives you a negative x cubed. 2 cubed is 8. 8 times 20. And the negative 1 gives you a negative 160 x cubed. So the coefficient is negative 160. So here's the x squared. Here's the x cubed. You need to remember that because these are linked problems. So we go down to the second part. We see the 2 minus x to the 6th again. That's what we had up here, 2 minus x to the 6th. So we're working with the same thing. Now we have a binomial in front. It wants us, notice the hence, meaning it's linked to the previous part. Find the coefficient of x cubed. So in order to get an x cubed, because this binomial has to be distributed through the binomial expansion of 2 minus x to the 6th. But we don't need all of the expansion. We just need the part that turns into a cube. So the 3x needs to be multiplied by x squared to get a cubed, and the 1 needs multiplied by a cube to get a cube. So here we have our 3x, and we need to multiply it by the square, which we had from this one right here, 240x squared. So we bring that in here, 3x times 240x squared, and we take the 1 times the cube from above, which was a negative 160x cubed. So this one up here equals 720x cubed. This one equals a negative 160x cubed. You subtract, and you get 560x cubed, and the coefficient is just 560. So you need, again, half of these math tests is mental strategy, mental compartmentalizing your what you've learned throughout the Pure 1 Maths book. So always keep your mind focused on what unit it comes from and your procedures, things like that. Now we get to a trigonometric show problem. So now we're in the trigonometry unit. And the first I noticed they want to get to a quadratic with all cosines. So this cosine will keep because it already is in cosine. And so this left one over here, notice on this one, it is not taking the left and making it equal to the right. This time, which it usually takes the left and make it equal the right. This time we're taking the whole equation and showing it turns into a different equation. So we can use both sides. Tangent is what stands out to me as one of our identities. So the first thing that I'm going to do is change it to its identity, sine over cosine. Well, that creates a fraction, and we don't like fractions, so we're going to multiply the entire equation by cosine to eliminate our fraction. So cosine times 1 is cosine. Cosine cancels out this cosine, giving us sine squared x. And then cosine times this gives us 5 cosine squared x. Well, we want the cosines. We don't want the sine squared. So we're going to use our identity here, 1 minus cosine squared. Replace the sine squared with that identity right there. And then we want to move everything to the right so that our cosine squared is positive. So when we add cosine squared over to the right, we get 6 cosine squared. Subtract the cosine x gives us negative cosine x, and subtract the 1 gives us minus 1. And now our equation is equal to the equation that they asked for. So we showed it. Now we see another hence, meaning it's linked. So instead of starting with our original equation, we're going to start with what we ended up with, this quadratic here. So we're going to start with our quadratic equals 0, and it says to solve it. And so we factor it. So the factors of 6 that add up to a -1 would be 2 and 3, with the 3 subtracting, or sorry, the 2 subtracting the 3 gives us a -1. So the factors of 6 are 2 and 3. The factors of 1 are 1 and 1. And we want the 3 to be negative. That's the nose in your smiley face method. And the mouth in your smiley face method, we want to be positive. So we want a -3 plus 2 gives us a -1, or you could say 2 minus 3 gives you a -1. So 2 times 3 is 6. -1 times 1 is -1, so it checks. Set each one of these equal to 0. You get cosine x equals a +1/2. And you get cosine x equals a -1/3 when you subtract 1 and divide by 3. Cosine is positive. This is where you do your quadrants. Whenever you do the inverse trig function is where we do our quadrants. So this is where you do your all students take calculus. Cosine is positive in the first and fourth quadrant. And over here on this one, when you do the inverse cosine, this one's negative. So cosine is negative in the second and third quadrant. The reason why I crossed out the fourth and the third is because our domain statement says just from 0 to 180. So again, pay attention, you're in degree mode on your calculator, not the radians mode. So check the mode on your calculator for degree mode. And this domain is only valid for the first and second quadrants. So I threw out the fourth and the third so we don't have to do extra work in finding those. So the inverse cosine of 1/2 is 60, and the inverse cosine of a -1/3 is 109.5. I just want to check really quickly if it actually gives it to you as the positive. Yeah, it already gives it to you as the positive. Just wanted to double check on that. And so there's our two answers. Here's our first quadrant answer, and there's our second quadrant answer, which both fit the domain statement. So moving on, we now have, here we are looking for a derivative, find dy dx. So now we're in the derivatives unit. Here's the original equation, y equals 12 over 3 minus 2x. Again, with derivatives and integrals, the formula is an exponent formula. So I bring the 3 minus 2x up and raise it to the -1 power. So 12 times 3 minus 2x to the -1 power. We're doing the derivative, which means first we multiply to the front. So now we have dy dx here because we're doing the derivative of y here. So we end up with dy dx. We don't need to separate our differentials for this. So this -1 times 12 is -12. Subtract 1 from the exponent gives us -2. So here we have -12, 3 minus 2x raised to the -2, and this is expanded form. Don't forget, this is expanded form. The exponent is not directly on the x, it's on the parenthesis. So inside the parenthesis, be careful not to jump to the conclusion that your derivative is 3. You have to look for the x. This is a constant. The derivative of that becomes 0. The derivative of -2x is the -2. So it's the -2 that we multiply here in our derivative. -2 times -12 becomes +24. And then to write this back into normal notation, our -2 exponent can move downstairs and become 3, or down into the denominator. I say downstairs, into the denominator. And 3 minus 2x now to the +2. So here's our dy dx. Now moving on, here we have an increase of rate problem. So again, that's a derivative question. And but now our change of x is with respect to time. So remember, rates deal with time. So we're still using the same derivative, but we need to separate our differentials. We want to check how the change in the y-axis with respect to time compared to the change in the x-axis with respect to time. So we need to multiply that dx to the other side. So again, that dx shows up over here. Then we divide both sides by dt, that's our change in time. So now we can see how the y-axis changes with respect to time, which it says right here, the y-coordinate increases, that means positive 0.4 units per second. So we replace dy dt with 0.4, and then our x-coordinate increases at a rate of 0.15. Again, it's increasing, so it's a positive 0.15. Decreasing would be negative. So this is increasing, both of them are increasing. So this one becomes 0.4 and the dx dt becomes 0.15. And we are looking for the possible x coordinates, means we're solving for our x, which is the only variable left in our equation. So since this is a fraction, we're going to multiply it over here. Now, between my work here and my work over here, I did kind of skip a couple of steps. So again, we're multiplying the 3 minus 2x squared over to the left-hand side. And then I expanded it. So 3 times 3 is 9. A negative 2x times 3 and a negative 2x times 3 is a negative 6 plus negative 6, which is a negative 12x. And then the negative 2x times negative 2x is a positive 4x squared. So this 3 minus 2x squared is expanded here on the left. I actually divided the 0.4 over to the other side, but I didn't show it. I just showed the net result. So 24 times 0.15 divided by the 0.4 is the 9 that you see over here on the right. So I did kind of skip a couple of steps. Sorry about that there. So this binomial got multiplied to the left and expanded. The 0.4 got divided to the right. So 24 times 0.15 divided by 0.4 is the 9 here on the right. So if you subtract 9 from both sides, they cancel out. Now there's a 4x common to both terms, and you get x minus 3 and 0 on the right. So you set each of those equal to 0, your zero product property. And so when you divide 4 into 0, you get 0. And when you solve for x minus 3 equals 0, you get x equals 3. So the possible x coordinates, plural, of A are 0 and 3. Moving on to number 9, here we have our circular measure problem that we covered at the end of I covered it at the end of the trigonometric unit. In the book, it's a separate chapter by itself. So first it shows us we have this large circle, or we have this smaller circle, I should say, with center A and radius R. So it shows the radius R going up. I also wrote it in going left. So here's R and R because it's from A to the circle. You could also put an R over here and over here if you wanted to. And then we have diameter CAD. Again, it's a diameter, meaning it's in the middle of the circle. And BAE, again, it's diameter, and they are perpendicular to each other. And then the larger circle has a center of B, and it passes, the circle passes through D and C. So it says, show that the radius of the larger circle is R root 2. Well, if you just look at this, hopefully you recognize this as a 45-45 right triangle where you have your 1, 1, root 2 special triangle. 1, 1, root 2 is just the coefficients. So this happens to be 1R, and root 2R has the variable in it, but it follows that 1, 1, root 2 pattern. So you should be able to see it straight from your special triangle. However, it says show, meaning we have to get the Cambridge grader to see what we're thinking. So we just use the Pythagorean theorem. R squared plus R squared equals the B to C squared. So A squared plus B squared equals C squared, our Pythagorean theorem. So R squared plus R squared is 2R squared. and then we square root that to get our BC, which is our radius of the big circle. And when you square root 2r squared, the square root of r squared is just r, and the 2 stays inside the radical as root 2. This then is the radius of our large circle. It is only 1 point. You're just doing the Pythagorean theorem. Now it says find the area of the shaded region in terms of r. Well, in terms of r means you're not going to get a numeric value. You're going to have to follow the formulas, and you're going to have r stay with you all the way through, and the area of the shaded region. So let's look at the shaded region here, which is this right here. If you can't see it very well in the video, this is the shaded region. So notice we have a semicircle, because this is the diameter. So we have a semicircle minus this little white part right here, which happens to be the top of a sector. So coming from the center of the circle B out to this arc length here of our big circle, this is the sector of a circle. So this B, C to D and back to B, that is a sector of a circle. And so what this white part is a segment. So to find the segment, you have to take the sector minus the triangle here on the left, gives you the segment on the right. Then we want to take the semicircle minus the segment to give us the shaded area. So here we have our semicircle. So half of a circle, semi is half the circle, CED, minus the segment, CAD. Well, the segment is the area of the sector minus the area of the triangle. Notice this negative between the two needs to distribute. So be careful that this negative stays on the outside, and that your segment formula, that is the area of the sector minus the area of the triangle, needs to be in parentheses, because this negative will have to distribute later on. So here we have our area of a semicircle is just 1/2 pi r squared. Again, check your radius in the diagram, and for our semicircle, the radius is r. So don't forget to check the diagram. Don't just put r in directly without looking, but it does happen to be r. Now minus, parenthesis, our area of a sector, which is 1/2 r squared theta. Well, our r is not r on the big circle. Our radius is r root 2. So we have 1/2 r root 2 squared. So here's our 1/2 r squared, which is r root 2 squared. And our theta, how do we find the theta? Well, if you recognize this as a 45 right triangle, then that means this is 45, and this one is also r root 2. That means this is 45. So two 45s add up to a 90. Or you can remember that any inscribed angle that opens to a diameter is a 90-degree angle. So you have two different ways at which you can determine this to be 90. Inscribed angle opening to a diameter is 90, or you recognize this as a 45 right triangle, and the bottom one is a 45 right triangle, and two 45s add up to 90. So two ways you can determine that. And remember, circular measure only works in radians, not degrees. So we use pi halves, not 90 degrees. Then minus the area of a triangle. Area of a triangle is 1/2 base times height. This is our triangle here. This BCD is our triangle. Here is the base, R and R. So we have 2R is the base and R is the height. So 1/2 base, which is 2R, and height is R. So the 2's cancel there. So overall, we have 1/2 pi r squared, that's our semicircle, minus, when you square this, the r squared shows up here. The root 2 squared becomes 2, cancels with this 2 in the back. So we still have our 1/2 in the front. The pi I moved to the front. Those 2's cancel, and we have r squared right here, minus These 2's cancel, and we have r squared again. Now we're distributing this negative. Remember, it's very important you pay attention to these parentheses so that when you distribute the negative, it applies to both terms. So here we have 1/2 r squared, or 1/2 pi r squared from the front, minus, I don't know why I switched it around, but minus 1/2 pi r squared right here. This minus and this minus, I think I put this in the front because it turned out being positive. I usually like the positive in the front. So minus a negative makes the r squared positive. These 2 are opposite signs, so they canceled out, leaving us with an answer of r squared. So our area in terms of r is just r squared. Now we move down to question number 10. This is also new content dealing with circles. Here is our circle. We know it's a circle because both x and y are squared. So x squared plus y squared plus it says the circle. X squared plus y squared plus 4x minus 2y minus 20 equals 0. With the center C passes through points A and B, state the coordinates of C. So there's 2 ways of doing it. One way I did it here in the paper, where you complete the square with your 2 x values. So x squared plus 4x. Here's the magic number, b divided by 2. 4 divided by 2 is 2. Squared is 4. And of course, we need to add that over here to the other side, which I combined with this one. So over here we have y squared minus 2y, and we need our magic number. So we have a negative 2 as our b term, divided by 2 is a negative 1, squared is a positive 1. So we have added 4 and 1 to the left-hand side, which is a total of 5. So we need to add 5 to the other side for our equalizing. This then, we've completed the square, so that turns into x plus 2 squared. This one turns into y minus 1 squared, and the 20 plus 5 is 25. So don't forget to take the opposite signs for your h and k. So the 2 connected to the x then becomes negative 2 as the x coordinate, and the negative 2 on the y becomes positive 1 here. So our center is negative 2, 1. And the square root of the 25, because this represents our r squared. So the square root of 25 is 5, the radius is 5. So our circle has a center of negative 2, 1 with a radius of 5. So let me just stop sharing for a second and show you here the board, and make sure that you can kind of see that. Over here, here's the other way that you can do it. Since it was already in its, say, general form, if you know where to look, you can find it a little faster doing this. Find your x term and divide it by negative 2. 4 divided by negative 2 is negative 2. Find your y term. Divide it by negative 2. Negative 2 divided by negative 2 is 1. So this is just the procedure you use if you want the fast way without completing the square twice. Find your x term, find your y term, divide them both by negative 2, and that will give you your x and y center. Then, to find the radius, you take your, if this is like your h and k, you take your x coordinate squared plus the y coordinate squared, and you subtract the c value. The c value is the constant at the end. You subtract it, so that means you get minus a negative 20. So negative 2 squared is 4, 1 squared is 1, and now we're adding 20, so that gives us 25, and we're square rooting it, which gives us 5. So this method is a little bit faster, but you need to remember how to do it correctly so that you don't mess up the problem. But this is an alternative way. I did show it in my video if you go back and look at the video. So let's go on to our screen sharing here. And we're now on to this one right here. It says also new material here. it's given that the midpoint of D, so here I drew a diagram. Make sure you draw yourself a diagram if you need a visual aid. So we have a circle, just a circle with a center, and D is the midpoint of this chord, okay, midpoint of AB. And up here it says that our circle passes through AB, meaning AB is on the circle. So I just put A and B wherever I wanted to it and draw a chord through the circle with D as the midpoint. Now, if D is the midpoint, remember from your geometric properties of circles back in IGCSE material, if you draw a line from the center to the middle of the chord, it will be perpendicular to the chord. Or if your chord is bisected, it also means that it's perpendicular. So if it bisects the chord, it's perpendicular, or if it's perpendicular, it bisects the chord. Since D is called the midpoint, it means it's bisecting the chord, cutting it in half. Therefore, this is perpendicular. Now, it asks us for the equation of AB, meaning a linear line, and it wants it in the slope-intercept form. So to get this slope, we need to first of all find CD. We don't know A and B, so we can't find its slope, but we do know C and D. We already found C up here, -2, 1, and D is given right here, 1.5 and 1.5. So we take our Y value, 1.5, minus the 1 from the center, and 1.5 minus the -2, and that gives us 0.5 over 3.5, which reduces to 1/7. If you move the decimal over, it's 5 over 35, which is 1/7. This is perpendicular, so the negative reciprocal becomes -7 will be our slope for AB. So we have y equals -7x plus c. We know that D is on the line. Don't use point C, it is not on the line. D is on the line AB, so we need to use that one, 1.5 and 1.5, or you could use 3/2 and 3/2. So that gives us 1.5 equals a -10.5 plus C. Add the 10.5 over, and C equals 12. So here we can find our equation, y equals -7x plus 12 is the equation of the line AB. Moving on, here we have another one. Find by calculation the coordinates of A and B, or just the x coordinates. So we don't need to find the y, just the x coordinates. So now we have A and B is on the circle and A and B are on the line. So we need to do simultaneous equations with a line and a circle. So we're just going to substitute the line right into our circle. So here's our x squared plus y squared, but we substitute our -7x plus 12 in for the y. Here's plus 4x minus 2 times y. Again, we make the substitution, -7x plus 12, and then the constant minus 20. Expand this square here. So that's the 49x squared minus 168x plus 144. Might need your calculator to help you on that. Here's the 4x. Distribute the -2 gives us 14x and minus 24, and then our constant at the end. When you combine these together, x squared and 49x squared gives us 50x squared, -168 plus 14x gives us a -150x, and then 144 minus 24 and minus 20 gives us 100. Notice they all share a 50 in columns in common, so divide out the 50 to simplify this a little bit. 50 divides into the 0, still have 0, so we get x squared minus 3x plus 2 equals 0. Now we can factor it quite easily. It looks like my right-hand parentheses here is a little faint, but x squared gives us x and x. The factors of 2 are 1 and 2. That add up to 3. Both signs are negative, and when you solve it, x equals 1 and x equals 2 using our zero property theorem, our zero product theorem. So here's our two x values, x equals 1 and x equals 2. One of them represents the x coordinate for A and the other one the x coordinate for B. Moving on to number 11. Here we have function notation here. f of x is x squared plus ax plus b, where a and b are constants. For this part, part A, we have a equals 6 and b equals a -8. So when we write out our function, I replaced f of x with y. X squared, our a is 6, so plus 6x, and b is a -8 minus 8. Now it asks us to find the range. Well, this is a quadratic, and we know that a quadratic, this one has a positive x squared, so it's a parabola that faces up. So we need to know the vertex so that we can determine the range, that is, where the y values go. So in order to determine the vertex, we complete the square. Again, completing the square. So this -8 doesn't work. We move it over here. So we have x squared plus 6x. This is the b. This 6 here is the b. Half of b is 3 squared is 9. So here's our plus 9. Over here we put our -9 because we're on the same side of the equal sign. So to equalize it, we have to do +9 and -9, but in two different locations. This part over here is now a perfect square, which becomes x plus 3 squared, and the -8 and -9 combine to make a -17, meaning our vertex is, we change the sign of the 3 because it's attached to the x, makes -3. The 17 is not attached to the y, so it stays the same sign of a -17. So we have -3, -17 as our vertex. Range deals with the y value, that's the -17. So our f of x, or you could put y, either one, y or f of x, is greater than or equal to -17 because our parabola is facing up. So it's going to start at the -17 and go up, greater than or equal to the -17. So there's our range. Then we move down here and it says, it is given instead, so in other words, we have a different case here, given instead that the a is 5, so I have x squared plus 5x. It does not tell us what the b is, so I just leave it as plus b. And it says that the roots of the equation f of x equals 0. So when you see f of x equals 0, that means you're given the answers. So our roots, our answers are k and -2k, where k is a constant. Now again, there's two ways of doing this. Here's one way I did on the paper, where I took my two answers and set them equal to x. So x equals k and x equals -2k. Those are the roots or the solutions. Then I work backwards. So I subtract k from both sides and I get x minus k equals 0. Add 2x to both sides, I get x plus 2x equals 0. I use our product, zero product property. So x minus k times x plus 2k has to equal 0. Then do the binomial expansion here. X times x is x squared. A positive 2x minus a kx is positive kx, and a negative k times 2k is a -2k squared. That equals 0. Now what I'm doing is equating coefficients. So here's x squared and x squared. Here's 5x and kx. That means the 5 has to be the k, equating coefficients. So this 5 and this k are in the same position. So k equals 5. The b is in the position of the constant, -2k squared. So b equals -2k squared. We already found k, plug it in. 5 squared is 25 times -2 is a -50. So b equals a -50. Now let me stop sharing so you can see the screen again. And notice, here's another way that you can do it. Notice it said f of x equals 0, meaning you can substitute the k in and evaluate it like a function. So if you plug the k into the function for x, you get k squared plus 5k plus b equals 0. That's the f of x equals 0, plugging in a k. You do it again, plugging in the 2k, or the -2k, and you get 4k squared. Put in a -2k, you get a -10k, and then plus b equals 0. Both of these equations equal 0. We have two unknowns, the k and b, solve simultaneous equations. They both equal 0, so set them equal to each other. So we subtract the k squared from this side, we get 3k squared. Subtract 5k from -10k, we get -15k. b minus b, or if you subtract b from both sides, it goes away, cancels out. So we end up with this, the 3k squared minus 15k equals 0. Factor out the 3k, you get k minus 5. Set them both equal to 0. No, we don't want k equaling 0, so we throw that one out. K still ends up equaling 5. Plug that back into either one of the equations. 5 squared plus 5 times 5 plus b. 5 squared is 25. 5 times 5 is 25 plus b equals 0. Therefore, b equals a negative 50. So you get the same answer, but it's just using function, evaluating functions for the values instead of the way I did it, using them as roots and working backwards from roots to factors to equation. Okay, so let's screen share again. We're almost done. We're doing pretty good here. Now we move on here. Show that the equation, so our function evaluated for x plus a equals a. So when we put x plus a into our x squared, we now have x plus a, and this is going back to the original. Okay, so our original x squared plus ax plus b. Okay, so when we plug in our x plus a to the x squared, we get x plus a squared. Then we plug it into the x and we get plus a times x plus a. Then here is our b, which was the constant at the end of the function. And this is said to be equal to a. So we expand out this binomial squared here, and we get x squared plus 2ax plus a squared. Distribute this a, we get ax plus a squared. Here's our constant b equals a. So now we have x squared. Here's a 2ax, and ax make 3ax. Here's a squared plus a squared is 2a squared. Subtract this a from the other side, plus b equals 0. Now, remember, this is our x squared term, so it has an understood 1 as a coefficient. That's the a. Ax squared plus bx plus c equals 0. So the 1, understood 1, is our a value on our quadratic. The b is a 3a, that's on our x term. Now, all of this here, the 2a squared minus a plus b, doesn't have an x in it. That means all three of those together make up the c, or the constant at the end. So notice it says a squared less than 4 times b minus a. Well, where does this come from? This comes from your discriminant. Hopefully you can recognize this as your discriminant, plus it tells you there's no real roots. So if you're dealing with number of solutions, that's your discriminant from the quadratics unit. So that means b squared minus 4ac has to be less than 0 in order to end up with no real solutions. So the b, again, is the 3a, just the coefficient of our x term. So 3a squared minus 4 times a. The a is not the a variable in this function notation. The a is our coefficient of the x squared term. So minus 4a being the 1, and then the c is all of this 2a squared minus a plus b is the c. So b squared minus 4ac is less than 0. So 3a squared is 9a squared, minus, distribute this negative 4. Don't forget the negative. Negative 4 times 2 makes a negative 8a squared. Negative 4 times negative a now makes a positive 4a, and negative 4 times b makes a negative 4b. So make sure you're distributing the negative with the 4 to all three terms. Now 9a squared minus 8a squared is just a squared. And notice we want the a squared by itself. Everything else needs to go to the other side. So here we have 4a minus 4b. We're going to move those to the other side. Since our minus 4b moving over becomes positive, I'll put it first. And then minus the 4a, since it's negative, I'll put it second. We factor out the 4 because we see that 4 there and there, and we get the b minus a left over. And we have shown what they wanted us to show. Now we move on to number 12, the last problem. Here we have this XY axis with this curve. By the way, this area, if you can't tell, this area under here is what's shaded. We have a B up here, which is said to be the maximum point. So I underlined it. We have A, which is also called the minimum point, A. You can also see that A and right here, those are zeros or roots or solutions to the equation. And if you notice, our function is actually in factored form. So it says the diagram shows the curve with y equals x times x minus 2 squared. The minimum point is the coordinate a0. The maximum coordinate is b, where a and b are constants. State the value of a. Notice it's only 1 point, meaning you should be able to recognize it by, or just recognition. Since this is already factored, you set the factors equal to 0. Why 0? Because y equals 0 is your x-axis. So when you replace y with 0, you're finding the location along the x-axis. A is on the x-axis. So you're either going to get x equals 0, with that point right here, or you take x minus 2 equals 0 and x equals 2. So that is going to be our location for A, because obviously it's not 0, which is at the origin. So x equals 2 is our A term. It was already factored. All you had to do was solve it. Now it says calculate the value of B. Well, B is said to be a maximum point. Well, maximum point is where first derivative equals 0. So now we have an issue here. While it is possible to do the derivative of a product, that is not taught until the Pure Maths 3 book. So in Pure Maths 1, we did not teach you how to do the product rule for derivative. So what we need to do to stay within the Pure Maths 1 teaching content, we need to expand this. You do not yet in Pure Maths 1 know how to multiply or to derive an x times an x term. So we need to expand our x minus 2 squared, which is x squared minus 4x plus 4, then multiply this x through it, and we get x cubed minus 4x squared plus 4x. Now that we have it separated out term by term, now we can apply the derivative rule that we learned in Pure Maths 1. And so here's our y prime, just showing the derivative. And then notice 3 multiplies to the front, becoming 3x squared. You subtract 1 from the exponent, so we get 3x squared. Multiply the 2 to the front, gives you negative 8. Subtract 1 from the 2 gives you an understood 1. And then we have an understood 1 on this x times 4 gives us 4. And when you subtract 1 from the 1, you get 0, which is why the x disappears. So we get 3x squared minus 8x plus 4. That is our derivative, but we need to set it equal to 0 and solve it because we're looking for the x coordinate of our b here. So notice my method here. I changed methods in factoring. I'm just showing you a different way that you can factor. Some students have difficulty with this factoring of quadratics where there's a term in the front, or coefficient in the front, and the constant in the back. 2 sets of numbers is difficult for some students to work with. So an option that you can do is multiply the 3 to the back and make 12. Factor the 12. That way you're only dealing with 1 set of numbers. The factors of 12 that add up to 8 are 2 and 6. Of course, they both have to be negative. Negative 2 and negative 6 make negative 8. So you get x minus 2 and x minus 6. So notice the negative 2 times negative 6 is 12. Negative 2 and negative 6 make negative 8. But since we multiplied by 3, this is the thing you have to remember. If you use this method, this is where you divide by 3. So you get x equals a positive 2/3. And when you set it equal to 0 and solve, you move the 2/3 to the other side. X equals 2/3 and also x equals 2. Well, obviously x cannot equal 2 because that's the value for a, so x must be the 2/3. So it says state the value of b, and b is down here on the x-axis. It's not actually up here on the curve, it's the x value. So the x value is 2/3. That's the value for our b. Now again, just to show you, you could have done it the normal way. You could have taken your 3x squared minus 8x plus 4. The factors of 3 are 1 and 3, and the factors of 4 are 1 and 4, 2 and 2. And you want the 2 times 3 is 6, and the 1 times 2 is 2 to give you your 8. So your 3x and your x, the factors of 4 are 2 and 2. Both signs have to be negative. And so you get 3x minus 2 equals 0, 3x equals 2, x equals 2/3. So you still get the 2/3. And here we have x minus 2 equals 0, so x equals 2. We didn't want the 2 because that was the value for the a, and we wanted the value for the b. So this is the normal way that I do factoring, but what I showed you in the paper was an alternate way if you have trouble factoring numbers in the front and in the back. So that was just an alternate way of doing it. Now we move on down. It says find area. Now you need to make a mental change here. You just got done dealing with derivative. Now it says area. Area is under integration, not under derivatives. So we got to change our mind to integration. Again, we want to keep the expanded form. We don't want to go back to this product up here because we don't know how to integrate a product. So we want to keep it in the expanded form that we had already found earlier with the x cubed minus 4x squared plus 4x. And the area of the shaded region is now from 0 to 2 because all of this in here is shaded. So from the origin to A is 0 to 2. So that's our bounds of integration, meaning we don't need the plus c. Here is our function. So remember, add 1, that gives us 4th power. Divide by that number, that's 1/4 x to the 4th. So here's 2 plus 1 is now 3x cubed. Divide by that number gives us a negative 4/3. Over here we have an understood 1 plus 1 gives us x squared. Divide by that 2, 4 divided by 2 is 2. So remember, simplify, integrate, evaluate. So up here we simplified from the product to our expanded form. Here we integrated, going from here down to here. Now we want to evaluate. So we do top minus bottom. So we plug the 2 in, we get 2 to the 4th power, 1/4 of 2 to the 4th, minus 4/3, 2 to the cubed, plus 2 times 2 squared. All of that minus, now we plug in a 0. Notice 0, 0, and 0. All of that just cancels out to 0. So 2 to the 4th is 16. 16 divided by 4 is 4. 2 cubed is 8. 4 times 8 is 32, so we have 32/3. 2 squared is 4. 2 times 4 is 8. 8 and 4 is 12. 12 minus 32/3. Well, again, you can use your calculator. I just got common denominator. 12 is 36/3. 36/3 minus 32/3 is 4/3. So 4/3 is the area. Again, they didn't really give us units up here. So if they don't give you units, don't worry about the units. You don't have to add units to it. Or if you wanted to, if you're really, some teachers are really strict on units. So if your teacher is really strict on units, just put units squared. So you don't have to say centimeters or meters. You can just put units squared, and that will be your units. So 4/3 is the answer. Then we have the gradient dy has a minimum. Now read it carefully. It's not asking you for the minimum of the original function. It says that your derivative, the gradient dy dx, has a minimum. So minimum and maximum is the first derivative of what you're referring to. So since we're referring to the first derivative, which we already saw, first derivative is 3x squared minus 8x plus 4. We got that right back here. 3x squared minus 8x plus 4 was our first derivative. Now what we want to do is the minimum of this is the next derivative. So actually, we're going to the second derivative of the original function, or we're going one derivative down from the first derivative. So multiply to the front. Now we went from integration back to derivative again, so make sure you set your mind to the derivative formula. Multiply to the front, you get 6, subtract 1, you get 1. Multiply to the front, you get -8, subtract 1, your x goes away. Derivative of a constant is 0, so we get second derivative is 6x minus 8. Set it equal to 0 because we're looking for a stationary point, that is a minimum or a maximum value. So we add 8 to the other side, divide by 6, we get 8/6, which is 4/3. Now it's not actually asking us for the x coordinate of the minimum. It says the minimum has a value m. How do you find the value? Well, you have to plug in your x coordinate to get the value. So notice m is not the x coordinate. What we found was the x coordinate of the minimum, and now we need to calculate its value by plugging it into the function that it relates to. And it's not relating back to the original function. This is a minimum of the first derivative. So we need to plug it into the first derivative because this is a minimum of our dy dx. So we did the first derivative of our first derivative, which is actually the second derivative of the original, set it equal to 0, got x equals 4/3. Now to find the value of m, we need to plug it into that first derivative. So our first derivative, our dy dx, or just f prime, evaluated for 4/3, gives us 3 times 4/3 squared. So that's this one right here. 3 times 4/3 squared minus 8 times 4/3 plus 4. This 4/3 squared is 16/9 times 3 is 16/3. 4/3 times 8 is a -32/3, and then here's our 4. Again, you can use your calculator. I got common denominator, and so 16/3, this is already thirds, so 4 is 12/3. And when you combine those together, you get the value of m, which is a -4/3. And here, congratulations, you have finished the specimen paper for the 2020 syllabus, which is our new syllabus. And we've shown a few alternate points. I'm not sure how long the video took, but I'm sure it was long enough. You can always go back, because I went kind of fast, you can always go back and stop at the questions that you need to stop at. You can always go back to the videos that taught those topics. Remember, Cambridge correlates information. So all the way through at each question, oh, this was from series. This one was from trigonometry. And notice the derivatives and integrals are all mixed up. You're doing a derivative, then you're doing integral, then you're doing derivative again. So you really need, it's mental focus and paying attention to the mechanics, also interpreting the questions correctly. But if you work hard at it, take notes, and again, work on your 7-5 ratio, 7 minutes to 5 question points. But you got to be able to get those 12 questions done in 1 hour and 50 minutes. So here we are at the end of the Pure Maths 1 book with one past paper or specimen paper completed. Congratulations, great job for completing Pure Maths 1. And I look forward to seeing you for the Statistics 1 series.